Hello, my fellow YouTubers. This is Roy back again. This video is going to be one that I've been wanting to find on YouTube 4 years ago. This one's going to be for the guys like me at that time got into Ed Lead Scallon, into Tesla, and got into some of the old physicists back in the day and electrical engineers, and just got me more pulled in and pulled in. Steinmetz, Tesla, Hertz, Maxwell, Faraday, Cooks, Edison, Franklin, Pythagoras. It's my electromagnetic wave. So, this video here, like I said, I wish I'd seen this because it would have explained it a little bit more. So this video here, let's start off from scratch, okay? So, got some plastic hanging here, and we're going to do a demonstration with this plastic on how I can use my body when the electromagnetic field is in operation, how it'll pull. That's my wind blowing from my mouth, but it'll pull to my hand and to certain objects, and we have other objects down here that we will check to see their reactance. In fact, I got some cool stuff around here somewhere. There you go. These are all real true flakes. So this is gold, silver, and copper. And we're going to spread that out down there and then mix the things, okay? So it's real gold flakes, real copper, real silver. And we're going to see what happens inside this electromagnetic area that I created, because we have a wall for it to bounce off, so it's getting absorbed. So exactly what's going on here is the electromagnetic wave is going this way. The electric wave is running upward, and well, actually downward, and the electromagnetic wave is running this way, and it's having a alternating effect. So it's rotating, rotating, rotating. And same thing is happening to this. Now this I have hooked up to a capacitor, and it's in tuned. I got it marked over here to where the tuning is to tune this, and it's very effective because it's the same length of wire there as the inductor. Okay, so let's go ahead and start off here. What we're working with is NST. It's a 15,000 volt, 30 milliamp. I blew out one side, go figure. So I'm only using 7,500 with 30 milliamps. And I know with the 15,000 volts, it had 450 watt capability. So I am using now 225 watt. Coming out of the hot side, going directly to the inductor. The inductor is 6 feet 3 inches, and so is that center length there. Coming out of the negative of the NST and coming into the spark gap, coming out of the spark gap to my saltwater capacitor through the top, filtering through the bottom, and going to the other end of the inductor. Now, when you run the positive side, you run the current this way towards us, you're going to be having a magnetic field vector created, and it's going to have direction of that way. So it'll be going in that direction. And if you reverse the field, then you would have direction going that way. So that's why we have this oscillating situation going on here in this environment. Okay, enough being said. Let's come over here for a second because I wanted to talk about, well, before I leave here, we got different stuff here. I got plastic and I got some glass and other things. I wanted to just explore a little bit and see what's lifting up and how things are reacting. Hopefully, we're in an okay environment. I don't get too shocked. I do need, there we go. I need a marker. So this whole couple experiments that I've done is leading me up to how a Tesla coil, basically a radio transmitter, transmits, and how you can send and propagate the electromagnetic wave to go over to infinite or go over to a resource where you're going to receive it. So it's all about the receiving, guys, okay? So let's just say over here we start off with our power supply, okay? Then we're going to come out of our power supply and we are going to have our transmission lines, okay? Now say of our transmission lines we speak about, say if we're looking to create, say, a half wave, okay? So let's just say we go start using a little ham stuff. So if we want to say be in a 30-meter band, okay, the frequency would be about 10.100, and in the half band we'll be looking at about 46.4 feet. So we need 46.4 feet, okay, 46. So that would be the length of wire that we would have for our transmission line. Okay? And that would be a frequency. My pen's dying. 10.100. Okay? So when you get to the antenna theory, if you say we want to work with the best current driven antenna would be a dipole, okay? Vinny, stop barking, okay? Now on the dipole, it's one of those referenced antennas I noticed. And one of the things that I like about it and what its main feature is that it's a really good gain. It gets good gain, and what I mean by gain, it's like a parameter gain is, and it puts direction. So if a Tesla coil here is putting out, radiating out of the wire in every direction, or a toroid out of every direction, we would make this antenna here that would take the field, and it would, instead of it being round, it would stretch the field out and elongate the field, okay? And what it literally does is snap. And remember, it's dipole, so that means one end over here is a positive, one end over here is a negative. So on the other end of this dipole, when it snaps out, depending on back what we talked about, which way you run the current, with a positive or a negative, in which direction you want it to go in. So if we wanted this to go in this direction, we would make sure we wind it to where the current is coming in one direction, okay? And that would send it out that way. And basically with this half wave dipole antenna, we can direct the radiation in one area versus it going everywhere and pretty much ruining everybody's TVs and everything. So this marker took a shit. So let's get out of that marker. Let's move to a black one. So anyway, so remember what's happening is when you come out of your transmission line, okay? If my video stops, this will be part one, okay? Out of your transmission line, the antenna really starts not at the length of this wire, but you do a 90-degree turn. And the second you do that 90-degree turn is when you now create your two dipoles. So this would be north up top, down here would be south, and now you're creating a magnetic field around this area. And now that we're oscillating it, we're going to have magnetic fields going both ways. So basically, we're going to be sending that out in our antenna directionally, bam, out the wazoo. Okay? So, of course, you guys, when you're working on your Tesla coil, you're going to have your, say, 4 inches is a good one to have, okay? And then you're going to have your wire running. Then you're going to have your primary, okay? And you guys are always messing with these top loads like that. And if you're looking just for sparks, I guess have at it. But if you're looking to send power across the lawn, then this is not what you want. But the toroid, what it does is create is a north and a south, and it has a magnetic field going out. Depends what direction you send it in, okay? It's going to have its point of vector going in a direction based on what you use here. So you could use the Tesla coil and you could get rid of the top load, come out of the top wire and come out of the bottom wire. Depending what you use to drive your system, you could tap off of that. If you needed that for, say, a transistor, you still could come off of this and go to the base of the transistor, okay? But if you come off of something big like NST or something, you're going to take this and this starts your transmission line. This right here starts your transmission line. And then go ahead and